Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter Introduction to Atom. In the earlier sessions, we have seen different concepts about the atom and subatomic particles, the discovery of these subatomic particles, and about arrangement of these fundamental particles also we have seen in the earlier sessions. Now, based upon those concepts, we are going to see a practice sheet. That is practice sheet 1, which includes conceptual understanding questions and single character answer type questions. Okay, let us start the practice sheet. See the first question. Let us go through conceptual understanding questions first. See the first one among those. The first atomic theory was proposed by. Who was the scientist who proposed this atomic theory for the first time to explain about the nature of atoms and the fundamental particle of every matter? He was John Dalton. John Dalton proposed first atomic theory to explain about the nature of matter. He considered that every matter is made up of tiny particles called atoms. These atoms are indivisible particles. Based upon that meaning only, the name atom was proposed for that particle. Okay, that was given by John Dalton. Next one. The idea of smallest unit of matter was proposed by. Actually, we told here the first atomic theory was proposed by John Dalton. But in fact, before him, in the 6th century itself, in the 6th century BC itself, one of the Indian philosopher and saint, he was Maharshi Kannad. He proposed in his literatures about this matter and its ultimate particles. He was Maharshi Kannad. He proposed that every matter is made up of small particles called anus. These anus are composite of paramanus. So here anu represents molecules. We know as every matter is made up of molecules. These molecules are made up of the combination of two or more smaller particles still, which we are calling as atoms. He called those atoms as paramanus. So the concept of anu and paramanu was proposed by Maharshi Kannad. Okay. Next one. The name atom means. So this is one of the atom is derived from one of the Greek words atomio, which means indivisible. At the starting, they considered these atoms are the smallest particles which are indivisible further. They named those particles as atoms. So the meaning of this word atom is indivisible. Okay, they consider these particles are indivisible, so they named those as atoms. Next, who proposed that matter is made up of extremely small particles called atoms? Who proposed it? He was John Dalton. John Dalton considered that every matter is made up of tiny particles which are indivisible further, and he called those small particles as atoms. Next, cathode rays were discovered by. Who discovered these cathode rays? Cathode rays nothing but electrons. They were discovered by J.J. Thomson. J. Thomson discovered these cathode rays by the help of discharge tube experiment. Isn't it? We have studied about this. When high voltage is applied through a gas taken at very low pressure in a discharge tube, then certain particles are emitted from cathode side and moved towards anode side, and they made scintillations on the screen kept at backside of anode. So he called those particles emitted from cathode side as cathode rays. Okay, that was done by J.J. Thomson by discharge tube experiment. Next one. What is the actual mass of proton? So say commonly the mass of proton is considered as 1 AMU, which is equal to 1.67 into 10 to the power of minus 24 grams. Okay, that is the actual mass of proton, 1.67 into 10 to the power of minus 24 grams. That is the mass of one proton. Okay, next, the name electron was given by. Yes, actually, at the starting, when they were discovered, these particles were called as cathode rays because these particles were discovered in the discharge tube experiment by J. Thomson. He observed these particles are being emitted from the side of cathode and traveled towards anode side. That is why he called those particles as cathode rays. These cathode rays were named later as electrons by the scientist G.J. Stoney, where it is here. Okay, these electrons were discovered by J. Thomson, but they were named as electron by G.J. Stoney. Okay, next one. Who discovered anode rays? So after the discovery of cathode rays, one doubt were aroused. That is, as atoms are being neutral, but they consist of negatively charged cathode ray particles inside. So as they're having negative charged particles, they should contain some positively charged particles also to counterbalance the negative charge of these cathode ray particles or electrons. So this doubt led to the discovery of these anode rays. These anode rays were discovered by Goldstein with the same experiment called discharge tube experiment. With the same experiment, Goldstein observed that certain particles other than these cathode ray particles which are moving from cathode side to anode side. Some other particles also being generated in the discharge tube and they are being traveled from anode side to cathode side and they are making scintillations on the screen kept at backside of cathode. So he called these particles as anode rays. So these anode rays were discovered by the scientist Goldstein for the first time. Okay. Anode rays were discovered by Goldstein. Next, what are the fundamental particles of an atom? What are fundamental particles actually to say? The particles which are existing inside the atom are called as subatomic particles. We know electrons, protons, neutrons, mesons, positrons, neutrinos. These all will come under subatomic particles because these all are found inside the atom. But out of these all, most stable and constant particles are three. They are electron, proton and neutron. That is why these three particles are specially called as fundamental particles of every matter. The fundamental particles of an atom. What are those three? Electrons, protons and neutrons. These are called fundamental particles. Now what we can take the answer? These three are correct. So this will be the correct answer. So all are called as subatomic particles. There will be around 100 types of fundamental particles existing in every atom. But out of those all, very important and constant stable particles are these three: electrons, protons and neutrons. That is why these three are specially called as fundamental particles of every atom. Okay, next one. The composition of alpha particle is the same as. We said here alpha particles are emitted from radioactive substances. So when the radioactive substances are being decomposed, they produce these alpha particles. Actually, alpha particle is nothing but a bunch of two protons and two neutrons. These all four particles together considered as one alpha particle, which has 4 units mass and 2 units positive charge because it contains 2 protons and 2 neutrons. Each proton mass is considered as 1 AMU commonly, isn't it? And each neutron mass is also considered as 1 AMU. Totally how many particles are there? 4 particles. That is why alpha particle mass is considered as 4 units or 4 AMU. At the same time, as it has 2 protons and 2 neutrons, each proton has 1 unit positive charge. As there are 2 protons, it carries totally 2 units positive charge, and there is no charge for neutrons as we know. Okay, alpha particles contain now 4 units mass and 2 units positive charge. The same properties will be there for the nucleus of helium also. We know helium atom contains 2 electrons, 2 protons and 2 neutrons. If you observe the nucleus of helium, that contains 2 units positive charge and 4 units mass because of the presence of 2 protons and 2 neutrons. So this is a similar composition with that of alpha particle. Now we can say the composition of an alpha particle is same as that of He2 plus ion. We can say helium nucleus. This is correct. Okay. Next, neutrons were discovered by. So after the discovery of electrons and protons, after so many years, they have discovered these neutrons. So this they discovered while calculating the atomic masses of the elements. They considered the mass of an atom is because of just protons, as atoms are containing only electrons and protons. We know electrons mass is negligible, so the mass of an atom is because of completely because of protons. So if the protons number is calculated, the mass can be assumed for that atom. But practically it is being different, except for hydrogen. Hydrogen has one electron and one proton. So the mass of hydrogen is nothing but mass of that one proton, 1 AMU. It is tallied there. But in case of remaining elements, for example, if you see in case of helium, it has 2 electrons and 2 protons. And the mass of 2 protons is to be the mass of helium as 2 units. But practically it was observed the mass of helium atom is 4 units. Means almost it is being double to that number of protons. Not only for helium, for almost for the remaining elements, it is being the mass is being greater in multiples of proton mass. From this, they came to one conclusion that there are some other particles also along with these electrons and protons inside the atoms with mass similar to that of proton and without any charge. So this doubt led to the discovery of neutrons. So these neutrons were discovered by James Chadwick. Okay, neutrons were discovered by James Chadwick. Let us see the next one. Now let us go through the single correct answer type questions. See the first one among those. The particle with no electric charge is. See here, the 3 fundamental particles are mentioned in this. Electrons, protons and neutrons. We know electrons are having negative charge, whereas the protons are having positive charge. The only particles present inside the atom with no charge are neutrons. Neutrons are having 1 unit mass, but they do not have any charge. So neutron is correct answer. Next one, the heaviest particle among the following. So among the fundamental particles, 3 fundamental particles, the heaviest particle is neutron. But to say in common, well, considering the mass of proton and neutron is considered as nearly 1 AMU, 1 atomic mass unit, and the mass of electron is considered as negligible when compared to the mass of these protons and neutrons. But to say accurately, the mass of proton is 1.007 AMU, whereas that of neutron is 1.008 AMU. Means the mass of neutron is slightly greater than that of proton. Even though they are having nearly same mass, but the mass of neutron is slightly greater than that of proton. Okay, that is why we can say the heaviest fundamental particles present in the atom is a neutron. Okay, next one. And if you say the mass of electron, it is almost negligible when compared to the mass of proton and neutron. Next, The subatomic particle having positive charge is named as. What is a subatomic particle with the positive charge? Totally there are majorly three fundamental particles, which are those electrons, protons and neutrons. Out of those three main particles, two are having charge, one is chargeless. The charged particles are electrons and protons. Out of these, electrons are having negative charge and protons are having same quantity of charge but positive charge. So the positive charged particles are protons. Proton is the particle with 1 unit positive charge on each particle, which is quantitatively equal to 1.602 into 10 to the power of minus 19 coulombs. This is a charge carried by each proton, which is considered as 1 unit positive charge. Next, the smallest particle of an element that displays the properties of that element is. Yes, the smallest particle of every element that displays the properties of that element is said to be an atom. Atom is the smallest particle of every matter which displays the properties of that element. Okay, it is atom. If you say carbon element, so in that the smallest particle is carbon atom. Carbon atom can display the properties of that carbon element. Okay, next one. Cathode rays are. What are cathode rays? Cathode rays are the stream of negatively charged particles called electrons. And here we can remember one point. Cathode rays properties are irrespective of the gas taken in the discharge tube. Whatever the gas we take in the discharge tube, on applying high voltage current, the negatively charged particles produced are cathode rays. They will be same in all the gases case. They won't be changed. So they consist negatively charged particles, electrons. So cathode rays are stream of electrons, where it is here. Okay, cathode rays are stream of electrons. Next one. The nature of anode rays depends upon. It is the only point which is being different from the properties of cathode rays. Of course, all the properties will be shown similar with anode rays and cathode rays, but in the opposite way. But here, it is being entirely different for anode rays. That is the nature of the particles in the anode rays. As we told, cathode rays are being independent of the gas taken in the discharge tube. Whatever the gas we take, the cathode rays produced will be having similar properties. They are containing negative charged particles, electrons only, whatever the gas we take in the discharge tube. But in the case of anode rays, it is being entirely different. The nature of anode rays depends upon the gas taken in the discharge tube. So from the gas to gas, the nature of these anode rays is being varied. For example, if hydrogen gas is taken in the discharge tube, then on applying high voltage current, this hydrogen gas splits into H plus ions and electron. Isn't it? Each hydrogen has one H plus one electron in it. On releasing that, it becomes H plus ion and the electron will be emitted. Here electron is a cathode ray particle and anode ray particle is H plus, which is containing only one proton. But if we take one more gas like helium, when high voltage current is applied in the discharge tube on helium gas at low pressure, that splits into He2 plus ion and electrons. So here again the cathode ray particles are same, electrons, but anode ray particles are He2 plus ions, which are different from that of hydrogen H plus, isn't it? H plus contains only one proton, whereas He2 plus ion, it has two protons and two neutrons. So in this way, the nature of anode ray particles is being dependent upon the gas taken in the discharge tube. That is why we say the E by M ratio of the anode rays depends upon the nature of the gas taken in the discharge tube. But whereas the nature of the E by M ratio of cathode rays is independent of the gas taken in the discharge tube. Whatever the gas you take, the properties of cathode rays produced will be similar in all cases. that differs only for anode rays. Among all kinds of anode rays, the smallest anode ray particle is considered as proton. But all anode rays are not protons. They may contain protons and neutrons also. Right? Remember this point. Now, the nature of anode rays depends upon the nature of the gas taken in the discharge tube. Okay? Next one. The charge to mass ratio of an electron. It is equal to 1.76 into 10 to the power of 11 coulombs per gram. Charge to mass ratio means E by M ratio. We know the charge of electron is 9.11, sorry, it is mass. Mass of the electron is 9.11 into 10 to the power of minus 28 grams or minus 31 kgs, because here all it are given the grams and kgs. Now let us take in the kgs. And the charge of electron is equal to 1.602 into 10 to the power of minus 19 coulombs, isn't it? Now if we calculate the charge by mass ratio, we get it as 1.6776 into 10 to the power of 11 coulombs per kg. Okay, that is also called specific charge of electron, or which is also called as E by M ratio. E represents here charge, M represents mass. E by M ratio or charge to mass ratio, which is also called as specific charge of electron. It is taken in coulombs per gram or coulombs per kg. Okay, now next question. Neutron is a fundamental particle which carries. What does it carry, neutron? We know it carries 1 unit mass and no charge. Neutrons are chargeless particles, neutral particles. So they have no charge, but they have 1 unit mass, that is 1 AMU mass, where it is neutrons carry no charge and mass of 1 unit. This is correct. Okay, next one. J. Thomson's atomic model is also called as. So after the discovery of electrons and protons, they raised one doubt there. As there are fundamental particles like electrons and protons existing in the atom, how do they exist inside? How they are arranged? To give answer for these questions, J. Thomson proposed an atomic model which is in comparison with the watermelon. So how red pulp is spread over in the watermelon, in the same way the positive mass is completely spread over in the atom, a spongy, just like spongy mass. And how black seeds are embedded in the watermelon red pulp, here electrons are also embedded in the positive mass. In this way, by comparing with the watermelon, he given a proposal of atomic model, that we can say the first atomic model proposed by J. Thomson. So as he compared this atomic model with the watermelon, it is also called as watermelon model. And with some other fruits also it can be compared like apple pie pudding model, and even it is also called as plum pudding model. So here what is given, watermelon model is also correct, and even apple pie plum pudding model also it is right. Even one more name, plum pudding model. Here the different models, these are the different names for the J. Thomson's atomic model because he compared his model with these fruits. How the fruit pulp is spread over in the fruit and how seeds are embedded in it. With that he compared these positive mass and electrons. That is why his model is also called as watermelon model and apple pie pudding model. These will be correct answers. Okay. This is practice sheet 1 on the introduction to atom chapter. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates on recorded videos.